All the rest of it was stuff that came from freeware or from packages that were available. So we could do a 2 million line of code application with very sophisticated capability with a very limited amount of that. And it was interesting because some of the companies that I'd worked with when I was at Rational would be building stuff from the ground up. In the meantime, these guys, just went out and got everything that was available and ran. It's there. So, you see that in terms of the apps that are available now that don't require that. So, the other thing I think is really down in the last couple of the domain knowledge that's necessary is, I think, very different and difficult to get. And in the business environment, those of you that are with Accenture will probably appreciate that this is still a problem, getting from the business analyst to the application. But in these new domains, that's an even bigger problem. So, the finding a way to get the combination of domain expertise about what area of knowledge it is that you're working and get that into the computer code that's necessary. It's eased a lot by the layers of abstraction. So you've got a lot less, people that know the domain are able to do a lot more, especially as the domain matures and the tools that are appropriate to develop in it. But that's still an area of challenge. I think the other thing that I want to talk a little bit about tonight is that just getting the knowledge and even encoding it is only a part of the problem. And in order to get real benefit out of it, you got to find a way to get it applied to a real world problem. And that's where I think there's the biggest challenges, actually. I think we'll find the computer science that we need if we understand well enough what it is we're trying to do. But getting it into the application, I think, requires a different kind of research than the technical research that you do. So the technical research is understanding how to build something or how to discover new knowledge that hasn't been there before. That knowledge is potentially applicable, but in order to understand where and how to apply it, you got to understand a lot more about the domain, and that's a different kind of knowledge creation, different kind of research than you have to have. And Frank and I were talking today about some of the creations out of research that are undoubtedly useful, but figuring out how to get it from a concept that could have a lot of power to something that is very specific and that people will use is a different kind of a challenge. So in that area, I think there's another thing that I see that I think is different, which is earlier in my career, at least I perceived that there were a limited number of solutions available to the problems I had. Today, it's almost the opposite. There's, if I just look at the App Store, I'm overwhelmed, right? Just that in itself. There's so much stuff that's coming at you that could potentially solve some problem or do something you want to do, that the first question is, is it a really serious problem I'm going to pay attention to, or is it really, really easy to apply? Because otherwise, there's just too much stuff coming at me. And I think those of us in the technical world are a little more amenable to stuff coming at us. The people in less technical environments are maybe not nearly as able to take on lots and lots of stuff. So there's a whole challenge of being ready. And I think what happens is that if I'm deciding whether I'm going to take on some new technology or a new approach, and that I've got to look not just at what the value of the solution is, but I've got to look at what's the cost, what's the risk, and how much time is it going to take me to do that. And that's a different kind of a problem than either technology people or I think salespeople have faced in the past, where classically a sales process or a buying process starts with recognition of need. But right now, there's so many needs I'm overwhelmed with needs. So it's not recognition of need, but selection of which one I'm going to pay attention to. That's a challenge. And I think that has, especially in applying to these new domains, has a particular set of challenges associated with it. So if you start looking at what are the kind of questions that somebody that's making a decision about whether to adopt new technology or not may be looking at, the first one is it even worth my time to investigate? Because the time, risk, and cost starts accumulating as soon as I start investigating, right? So I'm spending time, if not money, already in investigating it. and will it really solve the problem? And they're all too, in the software world, there are all too many cases of the promised solution not really working out when it got into real practice. And a lot of that came from some of the things further down, which is, do I have to integrate it with current tools? How does it work with my workflows? And if I'm looking at the medical analytics area, for example, it's going to be very interesting because the diagnostic process, an automated diagnostic process, is a lot different than most physicians are using right now. So there's a lot of workflow changes. There's a lot of different changes that are necessary. So understanding the domain is going to mean both understanding it from the point of view of being able to design a system that will solve the problem, but also being able to understand how that system will work into the current procedures, what has to change, and how it has to change. So that's part of why I think it's more about knowledge engineering than it is about just software. It's about creating a solution, designing and creating a solution that will enable people to not only to take advantage of the opportunity that's available with these new technologies and the new knowledge. So that, I think, is going to reignite the need for fundamental computer science to deal with the hard, deep problems underneath, and it's going to reignite the need to understand the application area and to get connected with it. So your world is going to be, I think, considerably more interesting in a lot of ways than the computer science world has been so far, and it's been pretty interesting already. So the thing that's the last point here, I think, is that, or maybe the middle point first, is that a lot of answering those questions are questions that as you're working in the technology area, you may not be able to answer. You probably need someone else with another perspective who may be closer to the domain, or maybe more around workflow and process orientation that can go out and work those for you. So you've got business issues that it's good to have help on, and you've got domain issues that are good to have help on. So in a lot of cases, you're going to be working with multidisciplinary teams that need to have all those different perspectives in order to create a solution that will be acceptable. And ultimately, that's going to mean that you're going to be most effective when you get out of your domain in the technical world and go out into the user domain and get some real first-hand insight and experience about what's going on. And I think in working with a number of university researchers over the last few years, it's interesting that the most interesting research projects have come out of the investigation into the outside world and what the problems were that people were having adopted. So, so it not only is useful in designing the right products, it's useful in knowing what problems people are having that if you can find a solution to, that will be applicable. So I think we'll have lots and lots of challenges. So, there are going to be lots and lots of new computer science side things, and the application domains are going to be continually changing. So, the learn to learn is going to be, lifelong learning is going to be even more relevant, I think, than it has been so far. So those are a few thoughts. We've probably got time for a few questions if anybody wants to or comments. Yeah.
When you say that knowledge engineering is becoming even more important, are you talking about just having, as opposed to having a person communicate with the computer and then the person carry out that action? Are you talking about a computer communicating with another computer and then the computers carrying out actions, kind of like a semantic web, so to speak?
Yeah, I think it's going to end up being all those. So, one classic case of I think where the different knowledge base is interesting is a friend of mine at Rational. His father had died with a heart disease that wasn't known or recognized when he was in his 50s, and Joe had an older brother who also died when he was 50. So Joe got very concerned about this, obviously. But it was very interesting that what happened between between Joe's brother's death was there was an accumulation of data about people that had had something similar to this. And so the first step in that process was a lot of analysis that wouldn't have been possible without the data collection, the sensors to collect the data, and then about the ability to crunch that data and find what was the real pattern in it. The good news was by the time Joe was looking into this, they discovered the pattern, and so it was a recognized disease, and there was a set of heart conditions or heart activities that could be monitored that indicated the onset of a seizure. So the first step was that's new knowledge. So that was real research that created brand new knowledge. The good news was that once that knowledge was created, it was possible using Medtronics and a few other people's heart monitors to be able to monitor for them. So the second stage was being able to real time take the knowledge and apply it to the question of, is this about to happen? The final step was really an important one, because then he just would have known he was about to die. The final step was embedding a defibrillator and tying it to the heart monitor. So the knowledge that had been created enabled an action that could be taken. And that actionable aspect is different than if you just knew about the disease. So you could know everything about the disease, but you couldn't do anything about it with traditional knowledge capabilities. But because the knowledge could be embedded in the process of real time, and it knew what action to take, you could tie it to an action. So in the end, Joe's twice while golfing, both times, has been hit with his defibrillator, indicating that golf may be a lot more stressful than he thought. But also making him much more concerned about software quality than he had been before. He wanted neither a false negative or a false positive in this case. It was an interesting experience. But I think that that leads to then sort of the ultimate integration, which is more and more of that data is coming in. Actually, it's being created by computers and by software that's doing the data in the first place. That can be automatically connected to the next system that can do the diagnosis and can apply it. But I think we'll see many, many more of those kinds of things where the data available needs to be analyzed and understood in a new way, and that new way will have implications in terms of what action needs to be taken.
Thank you.
I've got a little bit of a question for you. Now, you seems to make the right decision always. For example, Rational Software at that time is a tiny company, right? So you must see the potential, huge potential. You say, hey, I'm going to join the company. So what kind of advice you can give to students, because when they start their career, what kind of job they should look for? For example, you say they should accumulate not only computer science knowledge, but also application domain knowledge.
Or one or the other, and be understand what you're getting. Well, first of all, those decisions didn't always look nearly as good as they looked in the rearview mirror. Leaving HP in 1986 and going to a